Now, let's move on to the demonstration. Let's start with Floss, a tool that extracts strings from the malware. These strings are host-based indicators that can help us identify malicious activity on the system. Next, we upload the Wannacry sample to the PE Studio for a basic static analysis. PE Studio helps us identify key indicators like suspicious strings and the use of certain APIs. These are more host-based indicators that can help us understand the malware's behavior. Then, we use TCP view to monitor the network activity of the malware. We can see how WannaCry propagates by sending TCP packets over port 445, targeting computers in both local and wide area networks. After a bit, we'll notice a suspicious process starting a TCP listening port on 9050, which could indicate command and control activity. These are more network based indicators that can help us identify and detect the malware. So after resetting our virtual machine to a clean state, we fire up Procmon and set it to filter for processes containing WannaCry. So after we run the malware again, we can keep an eye on the processes that contain the word WannaCry. This is another form of host-based indicator showing us what processes the malware is creating on the host system. We can see that task sche.exe is a subprocess created by all the processes creating all of the processes containing the word WannaCry, and this sub process seems to be connecting to a random folder in program data. So let's take a look at this program data directory. It seems to be the staging area for the malware's execution. And if we open up Task Manager and navigate to Services tab, we see a service with the same name as the folder in program data, which starts automatically during startup. This is a clear sign of a persistence mechanism, another important host-based indicator. Finally, in Wireshark, we can see the infected computer making a request to the same URL we found earlier in Floss and PE Studio. This URL is the kill switch for WannaCry, and as soon as it fails to connect to that domain, it executes the payload. As we scroll down, we can see all the ARP broadcasts made to all the IPs in the local network, and TCP packets over port 445 being sent to random IP addresses. These are network based indicators that can help us understand the malware's network behavior.